Hi, my name is Kobi Hasharoni from Dustphotonics, and I will be describing the Applause project use case 3, passive fiber alignment for single-mode transceivers. Transceivers used in datacom applications, namely data centers and hyperscale cloud operators, are very abundant and are found in the hundreds of thousands per data center. They terminate the fiber links that connect the switches between themselves, the Ethernet switches, and the connection between the switches and the servers where the Ethernet is actually being run. The transceiver, even though pretty small, is a complicated device, and we can see on the left-hand side, on the electrical interface, we have a DSP, while on the right-hand side, the optical side, we have a fiber connector. There are also high-speed electronics, lasers, coupling optics for transmit and receive, and photodiodes. The market segment for these devices is again the cloud operators, the high-performance computing. It's a huge market with an annual growth rate of about 25%. Reducing the cost of these transceivers is essential for the growth of the network. The problem that we are facing is that of optical packaging. Namely, how do we couple the light from the laser to the fiber with as little labor and cost as possible? As we can see from the simulations here, the alignment tolerance are way below micron. Actually, we lose 1 dB of coupling power with several hundred of nanometers misalignment. And therefore, usually, either in the lab or in volume production, the coupling is done actively. Namely, we switch the laser on, we couple light into the fiber, and we monitor the amplitude with the power meter on the other side. This works well, however, it is very time-consuming, it has some yield implications, and therefore it is a major part of the transceiver cost. Reducing the cost via development of passive fiber alignment technologies is thus critical for volume production. The value chain for use case 3 is shown in this slide. It begins on the left-hand side with component manufacturer, photodiodes, lasers, technology developers based on flip chip assembly, and then system integration. The alignment technologies that we have been developing are being shown here. On the left-hand side, we see a self-aligned flip chip assembly of the laser. This alignment is done with respect to a silicon microbench in which the fiber and the coupling optics are defined by lithography, and therefore all of the components are on a single collinear line, on the optical axis. Another approach that we are developing is based on the BESI datacom machine, which is being altered in order to be able to run these passive assembly tasks as required by the coupling technology. Concurrently, we developed in this project the coupling optics for coupling light from the lasers to the fiber and from the fiber to the photodiode. Thank you for your attention, and if you have any questions, please stop by.